Hi, everyone. Welcome. Thanks for coming. We're going to get started today with our Apache Bigtop and Apache Apex native Hadoop meetup. We're going to start off with Roman Shaposhnik, Director of Open Source at Pivotal, committer at Apache Hadoop, and founder of Apache Bigtop. He's going to talk about making sense of Bigtop's role in ODPi and how it matters to Apache Apex. And then we're going to go with Chinmay, who's an engineer at DataTorrent and a committer at Apache Apex. And he's going to talk about, for ease of use and development, Apache Apex leverages Bigtop. Apex, being a part of Bigtop's stack, can be easily deployed in both RPM-based cluster systems and Debian cluster systems and run validation for installation. And so I'm going to give it over to Roman.
All right. Thank you so much for a nice introduction. Let me get my stuff over here. Hello, everyone. Thanks for coming. So we will be talking about ODPi, Bigtop, a couple of other things today. I like sort of these types of presentations to be as interactive as possible because my goal is to basically provide some, deconfusion, hopefully, because there's a lot of things going on in the big data space in sort of, streaming analytics, you name it. And at times it's actually tough to sort of make sense out of all of that. So that's goal number one. But the second goal is to basically recruit every single one of you. So I want every single one of you after this presentation is over, to head over to GitHub and make a couple of pull requests so I can accept them or not. But basically, please try to stay interactive or at least awake. So with that, okay, so what do I, okay. Yeah? Oh, okay, awesome. So all of the projects we will be talking about are built as part of the Apache Software Foundation. And even the slide deck is built under the Apache way. So there's a bunch of contributors to the slide deck. All of these awesome human beings are, Bigtop community contributors. So some of the stuff that I will be talking about, I was super surprised to actually see that they implemented it. And when they did, that made all the difference, because now Bigtop has all these other cool features. But what is Apache Bigtop? So for those of you who may not be familiar with the project, let's actually go through a couple of high-level points. So Apache Bigtop is kind of trying to be to big data and Hadoop what Debian is to Linux. So it basically tries to pull all these different bits and pieces together and present a coherent distribution, coherent sort of almost product to the end users. It is at the same time 100% open and community-driven distribution, just like Debian. What it means is that it's not being controlled by any corporate entity. Sort of you, as a user of technology, have as much right in telling what version of Apex needs to be included in Bigtop, or maybe sort of some other project, as anybody working for Cloudera or any of the big Hadoop vendors. It is basically a place where all of the communities around big data come together and sort of trying to figure out, how these different bits and pieces fit. Because a lot of times, in Apache, what you see is different projects being developed completely asynchronously. So something that may be happening, let's say, with Hadoop even itself, right? Something like, let's say, test development, maybe a little bit sort of opaque to, let's say, Mahout guys, and it takes them a little while to basically realize that they now have a different backend, available to them. So Bigtop is that place where all of these different communities actually get to talk to each other. It has, contributors from all the big names in the big, big data. Pretty much all of the big Hadoop distributions are building off of it. Not necessarily the latest version of Bigtop, but sort of the mechanics that I will be talking about today that most of the time, is what they're using, which means if you're going to apply to any of the Hadoop vendors or, DataTorrent, you will be familiar with what you will be working on, chances are. And it's a cutting-edge, quickly evolving distribution. So basically, we used to have this in Linux, right? Debian was the central place of integration between all of the GNU software and all of the sort of, the Linux kernel. And then a whole bunch of, downstream distributions came out of Debian. There was Ubuntu, obviously, but then there was Knoppix, first bootable Linux distribution, a couple of other things. And Bigtop is basically trying to do exactly the same. So to us, the kernel is still Hadoop. And by Hadoop, it's funny because, Hadoop used to mean MapReduce. Now it means, obviously Yarn and MapReduce and HDFS. But it's still sort of, we consider it still to be the kernel. And it's a useful way for us to think about, what's part of Bigtop and what is not part of Bigtop. Because a lot of people ask us like, well, what about, Cassandra, right? Well, Cassandra actually is nice and everything, but for the kind of, analytical workloads that HDFS is being used for, Cassandra is actually not a good replacement. So it's something that would be incompatible with our mission statement that, we are sort of, the kernel for us is still Hadoop, whatever Hadoop may end up being. So, just like with Debian, we basically have a whole bunch of downstream distributions, Cloudera, Hortonworks, still based on Bigtop. Now, we also have this meta distribution, which I will spend, next maybe 10 minutes talking about, called ODPi. So, this nice rocket ship. So what is ODPi? Well, there is a corporate sort of definition. So ODPi is a non-profit organization committed to simplification and standardization of the big data ecosystem by specifying the ODPi core. So what it means literally is that Hadoop ecosystem, unlike Linux, actually unlike Linux today, still suffers from essentially different vendors trying to outcompete each other by selectively picking and choosing what functionality they get out of the Apache projects into their Hadoop distributions, right? So you may have, Cloudera with one version of Hive and Hortonworks with a different version of Hive. Worse yet, you may actually have, different patches applied, on top of even the same version of the component. So all of these companies that are now part of the ODPi, and there's quite a bit of them, right? You basically have who's who of, enterprise software like IBM, EMC. I mean, Pivotal is definitely on the list. This is, by the way, a timeline. So this is, from February 2015 to, December 2015. So we're about a year and a half old. But you also have, guys like DataTorrent and essentially ISVs who are sick and tired of, testing for bajillion of different distributions and would like to have a common sort of ground on which they can deploy and rely. And that common ground is definitely not that. Because this is, by the way, a slide taken from the Gartner blog post. So I think it was Merv Adrian and a couple of other guys, but maybe just Merv, who was basically surveying the landscape of all the different Hadoop distributions and all of the sort of different Apache components that were part of the Hadoop distribution. And as you can see, it's basically an eye chart, right? So for somebody who is relying on, even like a handful of these components, testing a compatibility matrix is a nightmare. So ODPi is trying to standardize all of that, and we're doing it by the means of specifications and by the means of essentially having sort of a reference implementation that you can all test against. And even if you so decide, you can even sort of use it as a basis of your own distribution. So far, ODPi release 1.0.1. Like I said, we have a runtime specification, and just a second. And basically, oh, okay. So everything in ODPi, oh, okay. So I guess I'm just not showing this window. Showing screen. Show my screen, yes. Okay. I think I may have figured it out. No? No? Huh. Can I actually show the browser somehow? Oh, okay. Oh, okay. Okay. Got it now. Okay. That's good enough. Thank you. So basically, all of the ODPi development is driven out of the GitHub, so it's all open. We're not trying to be any kind of, sort of cabal of vendors, coming together and telling you what Hadoop needs to look like. So there's a bunch of repositories. There's a specification right here. That is basically a bunch of documents, kind of specifying in a very, RFC-like way of what a Hadoop distribution should be, what it should offer, what it should rely upon, like version of the JDK, different versions of the Linux operating system. We're taking a de facto approach. So basically, instead of trying to come up with a long specific, it's totally cool. The specification of all of the Hadoop APIs, we're basically saying ODPi reference implementation, and anything that's ODPi compatible has to be based on this version of Apache Hadoop that you can sort of take from the ASF. And that, by the way, sort of highlights one important thing about ODPi. ODPi is trying to be a forcing function to essentially make all of the vendors and all of the ISVs agree on what Hadoop is. We're not trying to hijack the Apache Software Foundation mission to develop the software. The software development still happens at ASF. So, for example, Cloudera, that is, a company that is still not part of the ODPi, they're still free to choose whatever they want Hadoop, definition to be, and pursue that, through the Apache software development, the sort of usual means of collaboration within the ASF. It's just that all of the vendors who I was showing you on the previous slides are essentially agreeing on a common definition, right? That definition will still have to be developed within the ASF, but at least we're giving you sort of the common set of versions, the common set of approaches, the common set of deployment practices. So right now we basically have, two specifications. One that was officially ratified, this is the runtime spec. And if you look at it, you would basically see very familiar language. So we're specifying that the ODPi compliant, distribution has to be based on Hadoop 2.7. So there's a whole bunch of statements that a compatible distribution basically has to, honor. And we have a validation test suite to make sure that all of the statements are actually validated. So as an ISV, as somebody who is developing an application or as somebody who is sort of trying to put Hadoop in production, you can basically sort of look through the spec and see what is guaranteed to you by an ODPi compliant vendor and what may be outside of the specification, then you are sort of on your own. So getting back to So getting back to what we have done, so again, there's a validation test suite. So basically, there's a bunch of tests that you can run against the distribution of Hadoop that is, from any vendor of your choosing, and see how much of that vendor, Hadoop distribution is compatible with the ODPi specification. There is a reference implementation of binaries. So if you are an ISV who is interested in testing against an ODPi compliant distribution, you can basically install a reference implementation from here, or you can declare a Maven dependency on a whole bunch of artifacts that are coming from this repository and test your application against ODPi reference implementation. So at Pivotal, we have a component called Hawk, which is a SQL on top of Hadoop. And recently, now that ODPi 1.0.1 is out, we decided to make sure that it's compatible. So we ran a whole bunch of test suites that we typically run to declare compatibility with anybody's Hadoop distribution. It all passed. So what we're now saying basically to our marketplace is this. If they run an ODPi compliant distribution, even if Pivotal is not supporting it officially yet, chances are that it only takes a single phone call and sort of ask of a sales representative or sales sort of manager of that account to basically ask us for support. Because the fact that Hawk is now ODPi sort of compatible, or at least being tested on the ODPi reference implementation, means that any other distribution, for example, like IBM's Hadoop distribution, will be a suitable platform for Hawk to be executed upon. So again, very selfishly, what Pivotal is getting out of it is much more increased market. So we don't have to worry about is that Hadoop distribution slightly different? Would we have to do something special in Hawk for that? Yada yada yada. We basically just tell everybody, if you want to be part of that marketplace, just be ODPi compliant, make your distribution sort of conform to this specification, and you're done. So what we're still working on at ODPi is operation specification. So all of the bits and pieces that tell you how to deploy and how to operate Hadoop in production. So that will cover some of the Ambari. But that will also go into the details of what Hadoop in the cloud needs to look like, stuff like that. So if you have opinions about that, or if you have a product in that area that may need to plug into the Ambari, let's say, now is a good time to basically jump on our GitHub and sort of start reviewing the specification. We're also working on the ISV ODPi sort of compatible policy, sort of in the same way that every Hadoop distribution company has a bunch of partners that they announce. We would like to have basically ISVs that are sort of officially blessed to be ODPi compatible. But we still have to develop essentially the same program that any company would have for announcing that somebody is a partner or technological partner of that company. So we're working on that. And obviously ODPi core today we decided to start small, so it just includes HDFS, MapReduce, Yarn, and Ambari. But we would like it to actually be much bigger. So one of the components that we are actively looking at, is definitely Hive, because SQL is pretty important these days on Hadoop. But we're also interested in your feedback. And in fact, at Hadoop Summit, or actually sort of close to Hadoop Summit time, next week, we will be running a meetup for people to kind of give us the feedback of what else do you feel should be the next step in ODPi standardization. Now, again, you should realize that we cannot really just give you everything in the kitchen sink because, something like it's easy to add stuff and it's pretty much next to impossible to remove stuff from a specification. So Hive is more or less a given, because everybody's interested in it. But what's next? Maybe it's a streaming component, maybe something like, Apex or something else, or Flink. So we're actually very actively looking for your feedback. And again, how can you help? You can share use cases with us. That would be absolutely amazing and awesome. And you can test against reference implementation, just like what Pivotal did. So if you have an application, even if you're just an open source developer, wouldn't you want to say, like, oh, my application, of course, can run on IBM's distribution of Hadoop? Well, now you sort of can, because IBM is about to announce that they're ODPi compliant distribution. And contribute to ASF projects. Like I said, ODPi is built on the notion that all of the software development actually happens sort of upstream from us at the level of ASF. So even the mechanics of build and packaging and tests, all of that comes from Apache Bigtop, which we will talk about in a minute. Hadoop is obviously from Apache Hadoop, so just contribute to the Apache projects. So with that, any questions about ODPi? Anything that's not clear? Alrighty, so let's switch gears a little bit and start talking about Bigtop. So what's inside of Bigtop? So let me just give you a laundry list, because Bigtop is kind of like a big tool chest. It has a lot of tools to help with what I would describe as first mile and last mile problems with Hadoop. Because if you find yourself in an environment, like suppose you're a data scientist, right? And suppose somebody else is managing Hadoop sort of deployment for you. So all you know is that when you run Hadoop command, it works. All you know is that when you run Mahout command, it works. All you know is that when you run like your sort of command line client for Apex, it works. You don't actually have to worry about much, except one thing: you still have to test. So when you are developing something that requires you to experiment with different versions of software, or maybe just to test in a constrained environment, you still have to test. So I call it a first mile problem. Like, you have to make sure that your software is good before you put it into the multi-tenant production environment. And the last mile problem is basically for anybody who is managing that environment, how can they know that it's safe for them to upgrade, that it's safe for them to sort of deploy the new version? So that's sort of the last mile problem. And Bigtop has the tools to help with all of that. So let's just go through these tools. So basically, it's a set of binary packages. And from that standpoint, it looks like any other distribution of Hadoop. So there's RPM packages, Debian packages, what have you. Integration code, basically bits and pieces of code that glue components together that, let's say, help you find Java, like really simple, not rocket science at all, but, useful. Or maybe they communicate to Hive, where to find, some of the jar files, that the Hive sort of needs, in certain cases, stuff like that. So packaging code is basically, your traditional sort of Unix packaging, but it goes beyond that. Deployment code, sort of what do you need to actually make sort of the instance of the Hadoop environment that Bigtop specifies. Orchestration code, sort of once you start dealing with especially public clouds, but even on the private clouds, you kind of have to have bits and pieces of functionality that allow you to orchestrate multiple machines. And there's basically validation code and continuous integration infrastructure. So let me go through each of those kind of in a quick succession, one by one. So integration and packaging, bunch of Linux packages. And so let me start showing you some real stuff. So this is basically Bigtop's continuous integration environment. So every night we build a whole bunch of packages for all of the components that are available in Bigtop. So if, for example, you are interested in installing, the latest version, well, from the Bigtop standpoint, not necessarily sort of the latest version from the project's standpoint of all of these projects, all you have to do is basically go to this matrix and let's pick Apex, right? So suppose you're interested in Apex on CentOS 7. So I just click here, and voila, I basically get my RPMs, tarballs, the whole sort of build infrastructure. So a lot of times what we do internally at Bigtop, we just point our sort of deployment code at these repos, and we just fetch packages, for testing purposes or validation purposes. You can do the same. And all of the code, all of the sort of code that makes it happen, basically lives in the Bigtop packages, location. So if we go and take a look, let's say at common, there will be Apex, right? So there's a whole bunch of integration code, not whole, like not big bunch, but some. So it's pretty easy to get a sense of what we're actually doing with it. And again, Apex is nice because it tries to be a nice, Yarn citizen. So it doesn't really require much from a traditional sort of Unix, deployment and Unix management perspective. But it's a good example of a small component that you can get your head around. Now, if you're interested in more of the sort of distribution, Linux distribution specific code, then you can go to either Debian or RPM. RPM is a little bit, I guess, more interesting. So there will be an Apex spec. That's just a spec file, tells how we package Apex. Again, very simple, because Apex is a nice component that, doesn't really, make us do weird things. But, a good starting point. So that's, packaging. And with that packaging, we are kind of done on Linux. But these days, Linux is a lot of times a good starting point, but it's not sufficient. Because after all, Linux packaging is very node-centric, right? You just basically provide an image for a node. And there is no notion of orchestration built in whatsoever. So a lot of times, we kind of try to experiment with the idea of smart tarballs, or Docker or Bosch images. So all of that experimentation is going on Bigtop right now. So one of the cool things that we're trying to do, we're trying to integrate with Docker Swarm and Docker Machine, so that you can basically orchestrate the entire cluster from a single command line. I'll talk about it in a minute. Tarballs, we kind of sort of played with it. But now that tarballs are being very quickly replaced by container images, I think tarballs were not really a good idea. So Cloudera is still stuck with them. They still use it for Cloudera Manager, but I think it was a bad idea to begin with. All right, so let me go back here. So integration testing is all based on iTest. And again, these are the tests that go beyond your traditional unit tests. So these are the tests that assume that the system is up and running. So these are the kind of tests that, for example, would test your Hadoop FS command, or they would insert a whole bunch of records into HBase and then run a pig script on top of that sort of a bunch of records. These are traditional sort of integration testing where you basically have the whole system as opposed to individual projects under test available to you. And you can do all sorts of things that might actually be difficult to do if you're confined just to unit tests. Now, from the other perspective, those are sort of like unit tests, the way we write them, because we use JUnit as an execution environment, to basically just get the test results. We are making you use JVM just for the benefit of ease of deployment and ease of management of sort of the code base. But we don't really care what language we use on top of JVM. So we started with a whole bunch of Java tests. Now we use Groovy. I think there's a couple of Scala tests, maybe even the code base. If COS was looking the other way, Scala may have crept in. But all we care about is that it's available on JVM and it's a versioned artifact. And the reason we want it to be a versioned artifact is because we want those tests to be available not just for Bigtop, but for all the other use cases that might come up. And I will explain some of these use cases. Because at the end of the day, we, within Bigtop, use those tests to make sure that the stuff we are sort of putting together as a distribution is a good distribution, right? That it doesn't break, that it does what it needs to do. But the very same question could be asked about the cluster that just got deployed, right? If you find yourself in an environment deploying a cluster, wouldn't it be great to run all of the Bigtop tests to make sure that your cluster is in a good shape? And that's exactly why we want tests to be available as Maven artifacts, versioned Maven artifacts, so you can reuse them and hold a different set of use cases. So again, to give you a practical sort of introduction, if you're interested in our test cases, okay, just a second. You would go to, okay. Okay. Just bear with me. Okay. Yes, cool. So you would basically go to the top level of Bigtop. Then there is Bigtop tests. So let's see, smoke test, for example. So here's Apex, right? So we click on Apex, and there's a Groovy script, pretty simple one, that basically does, some Hadoop manipulation, basically to sort of initialize, something in Hadoop. That's the, that's the teardown, that's the setup, So it basically builds, a bunch of things, the teardown we looked at, and then it just launches a job. It's interestingly enough, Bigtop tests, especially the smoke tests, which tend to be much simpler, are actually also a good starting point, for kind of like understanding how to use the component to begin with. Because, nowadays, most of the components have good documentation, but it used to be that it took a lot of time to just, figure out how to use a component. So Bigtop tests are actually a good place to do that. But again, if you want to write your own test for your own component, it's just as simple as dropping this type of, groovy test script. Like I said, we're using JUnit to basically just do sort of very simple, entry points into the test. So like every method, has to have like a test annotation so that the test execution framework knows what to call. Again, it's kind of useful to have after class and before class, sort of tear down and setup methods, stuff like that. But that's very familiar to anybody who's done any kind of Java development at all. So these are basically the tests. So what else do we have in Bigtop? All right. So finally, deployment. So once everything is built as packages, and you wrote your test, wouldn't it be nice to actually deploy the system to make sure that your test is functional, so that you can send me a pull request and ask to include your new component together with your integration test into Bigtop? Of course, it would be nice. So the way we do it in Bigtop is sort of twofold. On one hand, we want it to be just like anything else in Bigtop, a service that's available outside of what Bigtop is doing. And in a lot of environments today, still, people use Puppet for configuring sort of individual nodes. But we also want it to be useful to us because, again, it's a tool that we use internally to make sure that our distribution is good to go. So the way we use Puppet is this. So it has to be Puppet 3. That's the only sort of constraint that we put on you. But by now, like Puppet 2 is kind of legacy anyway. We typically prefer masterless Puppet, although the way we write scripts doesn't actually prevent you from using a master configuration. But everything that I will be talking about deployment-wise, later on is actually assuming masterless configuration. And for those of you, for those who are unfamiliar with what masterless Puppet is, it's basically, I guess, a hidden secret that you don't have to have a Puppet master to run Puppet. So if you have a bunch of Puppet code, all you have to have is a single sort of command, which is Puppet apply bunch of Puppet code. So there's no need for a Puppet master if you can do that. So that's what Bigtop does. And again, we have a bunch of recipes, a bunch of Puppet code that sort of offers you that functionality. All of the cluster topology is kept in a hierarchy file. And a typical hierarchy file for a cluster would look like this. So you would basically declare a bunch of key value pairs and sometimes arrays. Describing sort of a topology that goes outside of a single node. So like every node in a cluster needs to know where's the name node, right? Because that's the information that needs to be propagated throughout the cluster. Every node has to know where the storage directory is, for HDFS on a local node, stuff like that. And then, of course, at the Bigtop level itself, you have to tell Bigtop Puppet code what components you're interested in deploying. So once you have this hierarchy file, by the way, this is not a toy example. Like this is a real example. You can actually use it. All you have to do is make sure to run this Puppet command on every node, and off you go. Your cluster is up and running. So again, just to make it practical, let me show to you where all of this goodness lives. Okay. So anything that has to do with deployment basically exists at the level of Bigtop deploy. So if we're interested in the Puppet code, for Apex, all we have to do is go to Bigtop deploy Puppet. Then there's a bunch of modules that basically correspond to individual Hadoop components. And we go under modules, and there is Apex. So it's a bona fide, Puppet module that you can just plug in your environment. And like I said, most of the stuff that we do is masterless, but we have big German companies, well, companies too, okay, that use it in a master configuration, managing at least a couple hundred nodes, and it scales pretty well. So in this particular case, like if you look in the manifest, again, Apex is a nice component, so it doesn't actually require much. So I think it just basically says to install the package and not really much else. Let's take a look. Yeah, so the code is trivial. And again, this is great that I can demo Apex today, because it's a very nice, very sort of small component in the Hadoop ecosystem. It doesn't really require much manipulation. If I were demoing Hadoop Puppet code to you, that would be a couple dozen of pages of Puppet, because Hadoop has to take care of a lot of things. Now, what's nice about Bigtop is that it actually wraps that complexity up for you. So for example, a lot of times, when I find myself in need of setting up Kerberos, I would not even go to a tutorial on Kerberos. I would just go and grab Puppet code from Bigtop, and it would just like deploy Kerberos for me, because that's part of the thing that it does, for Hadoop, right? So it basically takes care of all of the gory details that otherwise, a component like either Ambari or Cloudera Manager would have to take care of, which is fine, but that makes you lose control. And my next slide will explain why control is important. So that's basically how Puppet is in Bigtop. So let's talk a little bit about retaining control. So what that fine-grained control allows us to do, it allows us to run Bigtop in a variety of different environments where tools like Cloudera Manager or Ambari become either clunky or impossible to use. So one example, because again, we still haven't really gotten to a point where you can have a functional Hadoop cluster on your laptop. So how do you get there? Well, one of the things that we do in Bigtop, we call it one-click Bigtop provisioning. This came from Trend Micro. They use it internally for all of the developers who are working with Hadoop clusters at Trend Micro, use Bigtop to basically spin up the development environments on their laptop in this particular way. So what happens is, the single command. That command, by the way, is part of the Bigtop. So like you just download Bigtop and run this command. You run docker hadoop sh-c number of local instances, local nodes that you're spinning up. And what happens then is there is a vagrant deployment code that basically spins up a bunch of Docker containers, does a whole bunch of Puppet applies within those Docker containers, and voila, you have a fully functional Hadoop cluster on your local laptop within seconds. Would it be possible to use Ambari for that? Yeah, absolutely. It'll just take a whole lot longer. And actually, in places like Docker Swarm, it won't work at all. So again, this fine-grained level of control over Puppet code allows us to basically put Bigtop into places where sort of a typical Hadoop distribution from a traditional vendor would not like to go. So that was actually pretty good. Like I said, Trend Micro built it for internal users. But then, because they're nice sort of citizens of Apache Software Foundation, they donated all the code back to Bigtop. So we're still using it for contributors. So if anybody asks me what's the easiest way to test sort of new contribution to Apache Bigtop, I just recommend you use sort of the vagrant provisioner, and whatever new addition to Bigtop that you are trying to make, just test it that way. And for vendors, it actually gives you CI out of the box. So if you want to have a CI pipeline that allows you to spin up quick, Hadoop environments, and especially if you're running something that already gives you Docker, like that's just the way to go. But we were still not quite satisfied with it, because it was, first of all, a little bit slower than what we wanted it to be. Still much faster than most of the alternative solutions. But it got into all sorts of weird corner cases that were tough to manage. And some of it actually had to do with the strategy of Docker Inc. So what we wanted to do with Docker wasn't really on the roadmap of Docker, because Docker wanted us to use You guessed it, Docker Compose and Docker Machine and Docker Swarm. So the bug, for example, that was open for 2 years, I mean, they were basically kind of like, if somebody fixes it, like, we'll accept the pull request, but it's not something that's important to us. So we finally gave in, and we embraced Docker Compose. So instead of Vagrant code now doing all of the management of individual VMs, we basically have Docker Compose, that does all of that. And the nice thing about that setup is that Docker Compose is actually compatible with Docker Machine, and here's why it's important. But let's look at the implementation first. So the implementation is actually still pretty simple. So the only thing that we need to communicate back to Docker Compose is, a number of sort of, instances, kind of the same way that we did with Vagrant. But we also need to provide volumes on which the Puppet configuration and Puppet code would come. And also we have to provide etc host. Again, pretty trivial bit of setup. The compatibility with Docker Machine and Docker Swarm is actually pretty awesome. And for those of you who don't know what Docker Machine and Docker Swarm are, these are basically the things that allow you to make no distinction between running on your local laptop and running in the cloud. So Docker Machine is the tool that, that gives you Docker engines on anything that you can possibly ask it for. And once you get it on your, let's say, Mac or Windows laptop, you don't actually need to have any other tool. So Vagrant kind of goes out of the window. Like, all of that mechanics is managed by the Docker Machine. But better yet, because it's the single piece of code that could either do it on your local laptop or sort of in the cloud, if, for example, you're satisfied with how it runs on your local laptop and you want to try it at scale on Amazon, all you have to do is run Docker Machine and ask for a bunch of Amazon instances. At that point, Bigtop code wouldn't care. Like, to Bigtop code, it's completely transparent, and it's actually a very nice way to test most of the things that we're doing. There's a couple of interesting, so I'm actually sort of running out of time. There's a couple interesting tangents in where Docker Compose is going right now. So DockerCon is going on like as we speak, I believe. At least it was going on yesterday, I think today as well. So the guy who did it in Bigtop is presenting at DockerCon, to like packed audience, because everybody wants to know how to better integrate with Bigtop code, on the Docker side, so that Hadoop can be one of the packaged applications that Docker Store, this new feature that the Docker company announced, could embrace. And speaking of which, that's actually the last part of my presentation, because there was a company that had a similar idea of a store of essentially distributed applications way before Docker had it. And that company is Canonical with Ubuntu. And the technology that I would look at right now is the last piece, sort of me explaining Bigtop. It's the Juju integration that Bigtop provides now. So you could think of Juju as an orchestration engine that runs on top of different clouds and allows you to basically run essentially fully distributed applications as though you were picking up applications from Apple, iTunes App Store. So you basically just point and click and you have your application running in the cloud. So like that's the whole promise of Juju. So for example, in order to deploy a fully functional Hadoop environment, all you have to do is run, like literally, run these two commands. Juju bootstrap, Juju deploy Hadoop processing. And the topology that would deploy is this. This is, by the way, from the Juju Charms website, so like just go there and check it out. All of the integration that Juju, that Canonical does, comes from Bigtop. And it's pretty cool because of a couple of reasons. So like suppose you deploy this configuration. So what we have here is basically, there is a slave node, there's a couple of ganglia nodes, there's a client over there. But it's a pretty default configuration. So, and all of a sudden we decide, well, we need to basically make this cluster bigger. So all you have to do is run this, and Juju spins additional slave nodes. Additional 2 slave nodes, your cluster just became 2 nodes bigger, just as simple as that. But wait, there's more. Remember I was explaining how we try to make our tests available in all sorts of other different contexts? So this is an example of that. So if you just deployed your cluster, Juju basically exposes Bigtop tests through the hook that they provide for testing the environments that they deploy. So if you're interested in sort of making sure that your name node is behaving, maybe upfront, or maybe you sort of suspect that it's misbehaving, you can actually run smoke tests on it, and that set of smoke tests would come from Bigtop. Or you can run a smoke test on Resource Manager, stuff like that. Juju is not really even Ubuntu specific. It's sort of focused on Ubuntu, pretty heavily, but you can run it on different distributions of Hadoop. And the whole idea for Juju is to basically be able to package all of the distributed applications as a single-click, installable artifact. So in fact, if you go to this URL, they would actually present you with the web UI that would ask for like your Amazon credentials or something, and you could just single-click a button and like off you go. So there was an awesome presentation at ApacheCon a couple of months ago by Zeppelin guys, who basically were explaining how they use Juju to run, Zeppelin notebooks, on demand, in their environment without really sort of like, without even knowing what's happening underneath. So like there's this whole Zeppelin thing, they just like, their users, all they know, they just click on it, like they're done. Pretty sweet stuff. Most of the, again, like I said, most of the code comes from Bigtop. So yeah, early mission accomplished. We basically have all of the Hadoop distributions, sort of using Bigtop. We do have the providers, which are not displaying quite well here, but let me give you a better picture. So this is, for example, a Trend Micro Bigtop big data stack, powered by Bigtop. So again, you could see components, different components. They sort of sub-selected it. They use Bigtop for upgrades because provisioning is so easy. They use it for testing that the upgrade would function. So they would basically spin up a cluster, and only like fetch a whole bunch of data from the old cluster, test it out, then sort of expand it. It's actually a pretty powerful set of tools that they've developed, but most of it, is actually available in Bigtop. And finally, before I completely run out of time, there's a couple of things that I'm really excited about in Bigtop, and that's sort of like I really would like to have more time to invest myself personally. And these are blueprints for data engineering. So these are the things that go outside of asking yourself, how can I just have a Hadoop cluster? Because that's kind of boring at the end of the day. Like, yes, there's a lot of mechanics that you have to sort of put in place, but at the end of the day, it's up and running, and what's next? What's next is, to my understanding, we basically have to invest in blueprints that is similar to like web application, sort of development blueprints, right? Everybody's familiar with, Pet Store, right? It's like Pet Store is how you start your, or used to at least, start your app, web application development career. Like, how can I implement Pet Store on Ruby on Rails or, J2E, right? We need stuff like that, but applied to data engineers, right? So we need to ask ourselves, what is the blueprint for an architecture that would be specific to, let's say, connected car, or let's say, financial vertical, or anything that ends up being useful, as an artifact, sort of a particular architectural instance that then can be generalized, to all sort of different other use cases. And we have a first example of that. So it's called Big Pet Store. It's kind of play on the Pet Store. So imagine that you were running Pet Store, for real, and then you would basically end up having a whole bunch of transactional data, right? Sort of that is the transactional data of your customers interacting with your web application, and there is essentially a blueprint of what would you do with that type of transactional data, being a data scientist and data engineer. So we have a data model, in Bigtop that was developed. We also have a transactional purchase model with essentially a generator that will generate, all sorts of dummy files that are representative of what would be happening in a real application. And then we essentially have all the hooks and bits and pieces in place to instantiate that type of architecture for you to take, for a spin, or maybe run benchmarks on, or maybe just learn and extend. So to me, this is one of the most exciting bits and pieces that I think exist in Bigtop today. So with that, I really think that if somebody comes up with a really good blueprint for Lambda sort of stream architecture, that would be really nice. So maybe it would be one of you. And a couple of just housekeeping items. We're trying to focus, like I said, more on data engineers these days, because sort of the original mission of being focused on DevOps is, we sort of like 90% done. There's still room for improvement, but focusing on data engineers is a big pivot, I guess, for the Bigtop community. And finally, data. So if you know good data sources, or good places where we can get our hands on something interesting, data models, data sources, let us know. So that's Bigtop. Thank you so much. Any questions? Yep.
How do you handle upgrades of Bigtop?
So upgrades are still tough. So most of the time, they are not upgrades in place. They are upgrades of essentially bringing up a different environment. A lot of times that different environment, because of the containerization, gets brought up on the same sort of underlying infrastructure, but that's sort of besides the point. And then it's essentially testing, validation, small amounts of DCP, at first, and then, full amounts of DCP.
So I have one more question about going back to your ODP slides. You mentioned the compatibility test suite that you have. What's the state of that test suite running on most recent distributions from these various?
I'm glad you asked.
Did any of them fully pass?
So the question is, what's the state of running on the recent distributions, the validation test suite? So remember how I told you that, everything that ODPi does is transparent? So we basically have this GitHub repo called self-certification reports. So let's take a look. So there's Hortonworks, and there's one. I thought there was a pull request. Oh, yes. And there's Altiscale pull request and Arena data pull request. So, pull requests are coming in. So you can actually take a look and, these are the people basically self-certifying, and just sending us sort of results of running the validation test suite.
Okay, thank you.
Mm-hmm. Any more questions, any suggestions, thoughts? All right, awesome. Well, thank you so much again.